Welcome.
To the joy of coding.
Hello, and welcome to episode 388 of The Joy of Coding. My name is Mike Conley. It's green. That's a problem. It's so good to have you here. My name is Mike Conley. Gonna be live hacking on, well, I don't know if we're gonna be live hacking on some Firefox stuff today. We might get there. Maybe. It's a special holiday episode, and I'm making stuff up. I thought maybe we could do something a little different today. But I'm going to run things by you. If you're in the chat, I didn't even check to see if the chat was working. Let me just make sure the chat is working. This is very last minute and harebrained. I ran upstairs and grabbed this hat and forgot that it's an elf hat and it's green. So of course it's just glitching right through. I just put my hand behind my head to see if you can see through my head. That's where my head is at. That's where my brain is at. I was like, oh, this is how green screen works. Maybe it's like an X-ray machine. If I could see my hand through this green hat, I would be astonished. I'd be like, wow, good for you, OBS. Your chroma key filter is working overtime. Let me just make sure that the chat is working because I want to make sure that I can see the commentary. I can see the commentary. Magical hat. How's it going, Smurf D? Good to see ya. Let me start by sharing my screen. Blah, blah, blah. Start by sharing my screen. And we can look at the agenda. Yeah, it's December 18th, 2024, episode 388. A reminder, no plan survives breakfast. I might have a giant gap in my green screen. That's fine. Things might go wrong. Things might go sideways. And we're just going to deal with it as they come. Hang on, let me just lower this a little bit so you don't have to see my carpet. I'm just going to be making stuff up today. Normally, whenever I stream, if this is your first time watching the stream, what I'm doing is I'm hacking on like Firefoxy things, and maybe that's what I'll do today. I have another idea that I thought might be fun, but I want to make sure that the people in the chat are aware that if what I do isn't fun and you find it boring or irrelevant and you'd rather I do something else, I'm open to suggestions. Think of me as like this is an open mic, and you can call out requests for things I might try over the next hour and a half. But here's what I was thinking. People who know me well, and maybe that's some of you on the stream, know that I have an affinity, a close affinity. That's being too clinical. I love adventure games. Point-and-click adventure games, particularly the 90s era point-and-click adventure games. We're talking LucasArts like Monkey Island, Day of the Tentacle, Sam & Max, The Dig, Full Throttle. We're talking Sierra, so the King's Quest series, the Space Quest series, the Laura Bow series, and then there's like the Telltale Sam & Max's. There's like some more modern point-and-click adventure games like Thimbleweed Park. There were some first-person ones like Myst is a classic first-person sort of like mysterious adventure game. The list goes on. There's plenty of them. I always enjoyed this. Like that's how I got into computing. Really, is I played a game that my uncle, who might be watching the stream. If my uncle is watching this stream, I'm gonna give some history here. When I was younger, my family got a new computer. As I recall, it was an Aptiva. It was an IBM Aptiva with a Pentium 100 processor, 100 megahertz, which at the time, that was like the Cadillac. That was like, whoa, you do 100 megahertz? Woo! Like that was cutting edge. It had a hard drive, which was new. I say new. Computers had hard drives before, but not any of my home computers, because I grew up with an 8088 IBM clone that only had floppy disks and no drive. So this was our first computer with like a hard drive. The first computer that had Windows. It came with 3.1. We eventually upgraded that to 95 and then 98. And it had a mouse. That was new. I'd never had a computer with a mouse before. I'd been always so jealous. I'd go to friends' places. They'd have computers with like a mouse and like Windows. They could play solitaire by like clicking and dragging. And so one of the things that happened when we got this computer is my uncle came over and brought a bunch of floppy disks with like a bunch of computer games that he had. And I don't know where these games came from, but one of the games was like if you'll pardon the pun, a game changer for me. It was this game called Simon the Sorcerer. This was one of the first adventure games I ever played, was Simon the Sorcerer. And I fell in love immediately. Oh man, this is, unfortunately, this is too small. You cannot see the artwork very well. But like, it was, here, this is more like it. This is what it was like. So pixelated, like 90s era graphics, but it was beautiful. And it like, they were kind of ripping off the LucasArts Verb thing, and you know, I didn't understand that was a thing at the time. I didn't understand that this was like a whole genre of game that was kind of in its heyday at the time. I just happened to get a copy of Simon the Sorcerer, played it, and fell in love with it. And then Monkey Island was next, I'm pretty sure. And then the Quest series, I started playing King's Quest. I'd actually played some of the Text Parser Quest games on our 8088, so I was familiar with King's Quest 1 and Space Quest 1. None of the sort of the EGA ones, none of the modern ones with a mouse. Just the sort of like really, really blocky text parser ones. Okay, so that's some of my history with adventure games. Now, why do I bring this up? What is the point of this? Why are we talking about this? Well, the point of this is because I was thinking maybe for a special holiday episode, we could look... I think I've done this before during special episodes where I'll look at an adventure game engine, and I don't think we've looked at this one before. This one's called AGS. This is actually... Oh man, you could really see the glitchy hat now. AGS stands for Adventure Game Studio, and this is a tool that you can use right now if you want. You can like go and download this tool. I think the tool runs on Windows only, unfortunately, but the engine, it's a game making tool. It's an adventure game making tool, and I believe the tool itself only works on Windows. But the engine that allows you to play the games is cross-platform. So you can play these games on macOS or Linux, or you can even play them in the browser. There's like an Emscripten port, which is kind of nice. And this has been used by... that's cool, it rhymes. This is... what's interesting about AGS is that it is still used today to make games that you may have even heard about. So one of the more famous ones is a game called, I think it's called Gemini Rue. This is from Wadget Eye Studios. These people have been doing a lot of work. This company has been doing a lot of work to like build. They're like an indie adventure game studio, and they make interesting point-and-click adventure games, like the kind that I love growing up. And this one, Gemini Rue, is one I played on my phone. And it happened to, it's like a cyberpunk vibe, and it's written using Adventure Game Studio. And this like did fairly well, as I understand it. Like it won a bunch of awards. It was PC Gamer US Adventure Game of the Year 2011. Back when PC Gamer had this award, Adventure Game of the Year. I don't know if it still has that award. But the game engine is used for like games, not just like little projects. You know, here's a demo of a game and then no one else ever uses it. Like a lot of games use this thing. And there are like the AGS awards. You can see a full list of games that people have played, and some of them like are just like people dipping their toes in and getting used to the game engines. Like some of the games. You can go to this website, adventuregamestudio.co.uk. I'll actually put that in the agenda here. You can go there and you can get a wide variety of quality of games, quality of graphics, quality of like storytelling and puzzle design, etc. It's the full gamut because like anyone can make these things, and so you're gonna see lots of variety. And yeah, Gemini Rue's listed here. There's one called The Journey Down Over the Edge. Heroine's Quest, all the way down to like you can get like text parser games. Blackwell Epiphany, that one is also from Wadget Eye. There's one called Kathy Rain. I really enjoyed this one. This one was also AGS. And so a lot of the things that you might remember from if you had ever played point-click adventure games, like you can get like the verb menu at the top, like sort of the Sierra style from like the mid 90s. You can do text parsers. You can do the verb grid a la LucasArts if you really, really want. You can make up your own novel interface for your adventure game. I think it's kind of neat. So this isn't a plug for Adventure Game Studio. Like, I'm not being paid, obviously. Like, it sounds like a plug. I'm not being paid by Adventure Game Studio. But I thought we could examine some of its source code, because guess what? It's open source. Sometime in the past, I don't know, I don't remember what year it was, but it was like not too long ago, within the past 10 years, because like originally it was a closed source engine. It was one person maintaining this thing, building and maintaining this thing, and then they open sourced it. Within the past, I'd say 10, 15 years, somewhere in there. And it's an active development community is keeping this thing alive and doing things like script imports, and games are still being made for it, and I think that's pretty neat. And so I thought we could take a look at some of the source code, just kind of explore it, just to see what it does. In particular, I was hoping we could look at some of the engine's source code, as opposed to like the tool for building the games, which might also be interesting, but in a different way. Like, that's interesting because you can see what it's like to build like a Windows GUI, I guess, and like write files and, you know, asset management and stuff. And you can see sort of the other half of a game engine is the tool that builds the assets that are executed by a game engine. And then there's the engine itself, the part that interprets a game and its assets and does things on the platform with them. And then there's like game source code itself. Some of these games are definitely not open source. Like, I believe there's nothing in the Adventure Game Studio license that forbids you from withholding the source or releasing the source. I think you, as the game engine or the game author, you can choose to do either. But I believe a lot of games are written and the source code is not released. But I'll bet you can also find ones with their source code available. But I wanted to take a look at some of the source code for AGS. Now, if at any point during this exploration you're like, this is terrible viewing, I don't want to do this, I signed up to watch someone hack through some Firefox stuff. If there's something else you'd rather I do, just I found this channel last week. So this is a message from FCK World. And they say, to be honest, I just found this channel last week and I'm really tired of the typical software development coding streaming. So this really looks dope. It looks dope, according to FCK World. Well, cool. I'm glad you like that, because like I have not explored this source code before. And so we're going to be looking at it together for the first time. I'm going to be exploring it with you, really. And we can you can observe how I explore a new unfamiliar code base and sort of make assumptions and pick it apart a little bit. I'm not going to be critiquing it. I'm more just going to try and understand how it works. And I don't know how far we're going to get. I've already blown like 16 minutes of time during the stream. So maybe we should just get started. I'm going to start. I'm also, for the holidays, I'm going to start some light background music. If that's too loud or too quiet, let me know. But I thought we could have some holiday mood. How's that going in the background there? Just a little bit of light jazz. Okay, let's take a look at some source code. So here's the source code. It's at this is the GitHub repository. Let me drop that in the agenda as well. By the way, if you're not familiar with the agenda, if you're like FCK World and you're a brand new viewer, the link to the agenda is down in the channel details. If you're watching this on Twitch, it's down in the details section. It's over in the details section if you're on Air Mozilla. It's down in the description, video description if you're on YouTube. And as I update the agenda and this little spinny spins, it should update if you hit reload. Okay, so this is the source code for AGS. And it's still being actively developed. Someone landed something yesterday. There are 7 pull requests, 256 issues. I think they're doing most of their development in GitHub. That's interesting. And some of these things are like, they have not been touched. Like 8 years ago was the Git modules was touched. 5 years ago, like when was the license touched? 12 years ago. Move license to the top. And listing the copyright holders. So it's licensed under the Artistic License 2.0. Okay, interesting. So like that might be a decent estimate for when this thing was open sourced, is 2012. I'm gonna say that that's my guess, is in the 2012, somewhere in there. So we've got this is a fairly typical project architecture where you've got like, here's all your sort of like configuration stuff. They're using CMake, it looks like, for building. There's some documentation. That's nice. There's a version.json, which this I've never seen something like this before, but maybe this is being used by a build tool to like inject some values into the build, like the version and the maybe the month it was thing it was built for, and like some kind of UUID here and a link to the license and all these things. And it looks like there's some dependencies. So this is an interesting one because I'm reasonably certain. So I said I haven't looked at the source code before. This is true. I've never done a deep dive. I have seen that because like I was aware that this code had become available. I'm actually surprised to see this because I recall AGS using Allegro. And I know this because one of the things, when they open sourced it, I remember one of the first things that I thought was, I want to port this to the web. I want to try and use Emscripten to port the engine to the web. But one of the problems was that it was using this tool called Allegro. It was using that library, Allegro library. Allegro is like a game programming library from like back in the day. This thing is old, but you know, still having releases. Like they had a release last month. Allegro 5, 2.10 was released. And if you're familiar with SDL, which is like an abstraction layer with which you can write games to do, so it takes care of like graphics abstraction, input abstraction, audio, like that's all that sort of stuff. It takes care of a lot of that for you in a platform agnostic way. Allegro is similar, where it's like it's mostly platform agnostic. It supports these platforms. You can use it from C and C++, and it takes care of a lot of stuff for you, like it like setting up a rectangle within which you can blitz some graphics. It'll take care of it for you, and it'll do it very efficiently. It's not a game engine. It's similar to SDL. Anyways, Emscripten, the tool to port something like a video game to the web so it runs in your browser, uses SDL. Like that's what it knows how to convert to the web is SDL, which, if you're not familiar, is the simple direct media layer. And this is used by lots of stuff. And it's supported on all of those other platforms that Allegro supports, but it's used. I think this has kind of won the battle, if I had to say. Like this is used by like AAA games right now. SDL. libsdl.org if you're at all interested. So Allegro and SDL. And it looks like at some point they switched AGS from using Allegro to SDL, and that was one of the things that prevented a conversion. Like it basically stopped me in my tracks. I'm like, okay, well I can't just use Emscripten to compile this thing to the web. It needs to use SDL, and it looks like they did that. So that's interesting. Let's keep going. So there's a couple of different parts to AGS. I think I had mentioned it. There's like there's the engine that interprets the game, and there's the tool for building the games that the engine will then interpret. I'm hoping to look at the engine, and I believe it's here. Oh, sorry, that's editor. Sorry, here, the engine. I think that's it. That's probably it. There's a bunch of other stuff as well. I don't know what libsource is. These look like maybe platform-specific bits and pieces. iOS, Debian, Windows. There's probably one, Mac OS is right here. OS X. There's something called Common. Android. What's in Common, for example? It's interesting. Common and then platform Windows. I don't know what. And there's like a Windows header in here. You know what? I think I understand. Common is something that is not common between the platforms, but is maybe common between the engine and the editor. That's going to be my assumption moving forward. Is that that's what it means by common? Like, because those are two different executables. You've got the you've got two projects living in the same repository here, and I suspect that common is being used by both of those sub-projects, those executables, the engine and the editor. Compiler is probably also part of the editor, like the tool for building your games. Like one of the things that you can do with AGS is you can script your games. You can write, I don't remember what the script is called, the language. Scripting tutorial. AGS, all interactivity in the game is handled using scripts. I don't know what they call their scripts, but it looks kind of like it's like a C-like language. Or like it reminds me of any like C-like language, or maybe like a basic. It's, I think, object oriented, so you can like call methods on objects. It's object based. It's just called the AGS script language. They didn't give it a fancy name as far as I can tell. And then yes, some interesting facts about their scripting languages here. But ultimately, there is a scripting language, and that scripting language looks like it's compiled. So whenever you download a game like Gemini Rue, you're not going to get the full-blown scripts. It's probably going to take those scripts and convert them into some kind of binary format, some kind of bytecode that is then interpreted by the engine to execute the game logic. Which that is classic adventure game move. You know, if you're familiar with Scum, if you're familiar with AGI or SCI, these are the adventure game engines from Sierra and LucasArts respectively. I think I swapped them around. Scum was the LucasArts one. That's how they worked. You have like a single engine, or sorry, you have a single I'm oversimplifying it, but basically you write your game once and then you have an engine interpret it for each of the different platforms. Kind of like Java before Java existed. Write once, interpret everywhere. Or compile once, interpret everywhere. And so that's what's going on here. You have this like abstraction where the game logic is like in this cross-platform format, and the engine runs on the different platforms. So let's get into it. Let's look at this engine. What are we waiting for? Okay, so the engine has its make file here. There's a bunch of definitions for some different platforms. There's one here that still mentions Allegro. That's interesting. And I'll bet you, to be clear, that this is the part that was Emscriptionified. You know, I think the Emscripten part, because I like opened this up real quick when I was looking at this. I think it's a port, or maybe it's not a port. No, it's in the main tree. So maybe it's not like they forked the source code to make it work with Emscripten. They did something else. There's just like a little bit of build gunk in here. Sorry, that's the same thing. That's the file that we're looking at. Install dependencies. This just gets you the Emscripten tool. And then there's like a boilerplate like HTML document for your game to run in. And then there's like a bunch of sort of like boilerplate hooks for the game engine to talk to your browser. And then where am I? And then there's some more script in here. Oh, this is just like, hey, yeah, fill this array with all your game files and put them in the same location. I guess this is what you need to change if you're making a game. Use this thing. And then this is some stuff, I guess, to convince the engine when it's running in the browser that you can do things like make directories and mount directories and sync to the file system and stuff. Oh. Let's not dive too deep into the Emscripten port though. Let's keep looking at the engine itself. So in this directory structure, there's lots of folders, and there's one very handy called main. I keep seeing this convention. There's libsource. I saw it at the top here. Libsource, and I saw it under common, libsource, and I don't know what that means. I'm very curious what that means. That's my very first question, is what does libsource mean? Okay, I think this means vendor. This is the equivalent of vendor. These are shared libraries, like external libraries. So we've got, I'm not sure what APEG is. Maybe this is some kind of like, what is APEG? And okay, so this might be video. This is APEG 121. GLAD, GLES. This might be like 3D graphics. OpenGL, ESLoader. Okay, this is some kind of OpenGL library. I think these two are kind of like related to one another. There's something called libcda. I don't know what that is. Libcda is a cross-platform CD playing library in case you want to play CD audio. Woo! There's OGG for some audio. OGG and Theora. Theora, there's just a CMake in here for Theora. But that's interesting. So LibSource is just vendored libraries, external libraries, and dependencies. Okay, got it. We've got a couple of other things in here. We've got platform. These might be like, yeah, the different platforms specific things that are implemented. So for, it looks like there's just like a single file for the Emscripten one. It's a little more complicated for the Windows stuff, but I would imagine that this is how, like, there's going to be a common base, and then the platforms like implement and subclass parts of the base would be. This is a pattern that we use in Firefox as well, where like there's a platform generic widget layer, and then we have individual implementation of those widgets. One for Linux and GTK, one for Mac OS with Cocoa, and one for Windows, like using the Win32 libraries. And there used to be one for like OS2 and stuff. And so I would imagine that there's going to be some like subclassing going on in here, where like you subclass, AGS platform driver is probably the thing, and you subclass those things with your platform specific gunk, and then the engine just knows that it needs to talk to something of this shape to talk to the platform, and it doesn't need to necessarily care about the platform it's running on. That is a pattern we use in the Firefox, like the Gecko engine. That's like classic cross-platform pattern. Okay. So this is tantalizing. Main. That's going to be my first thing that I want to look at. Let's look at main. Because this is probably your main. This is your entry point, almost certainly. Like, we won't know until we find int main, which is like, this is a C++ program. Int main is where the C++ compiler is going to send you the program to whenever it launches. So let's see if we can find int main. It's probably in main.cpp. That's a very good, that's like, we can assume that. Let's check, but that's a fairly strong assumption, I think, that I think we can make. So let's take a look in main CPP. Hey, entry point of the application. Great. So let's dig in. All right, grab your knife and fork, everybody. Let's see what's going on here. Hold on a sec. All right, grab your knife and fork. Let's check it out. So we're including a bunch of stuff. So part of deep diving into source code like this, especially if I'm just like trying to become familiar with it, is learning what you can probably safely ignore and either come back to later or come back to never. And like, I don't really super care about the includes right from the top. I'll tell you what I'm looking for is I'm going to be looking for int main. I'm also going to look for everything that it's setting up before it gets to int main. That seems interesting, but I'm not going to be doing a deep dive. I'm looking at the overall structure of this file. I'm looking to see like the number of things it's trying to set up before it gets to int main, and then I'm really interested in seeing what int main does, and that might send us out to reading other parts of the source code. So let's quickly see here. Like, even though this is interesting, even though we're supposed to be platform agnostic, and this happens in Gecko as well, every now and then you will need to do something kind of platform specific in your source code that's outside of the platform directory. It's the abstraction leaks a little bit is what we would say. And so there's a little bit of if-defing of like, hey, are we compiling for Windows? Or are we compiling for Windows and it's not debug, and we're not compiling for Windows using MinGW, I guess? And you can define some stuff. Okay, using namespace. We set up some globals. This is interesting. Global variables, not static. That's interesting. Okay, main init. So that's not int main. This is separate from main int main. This is something called main init. It's being passed what I would normally pass int main, but I'm guessing that this is another abstraction away from int main, because for ports like Emscripten, you you might need to like do some things first before you call your primary routines. Let's just keep going though. That's interesting. A main init, which isn't int main. And then there's this utility for getting some kind of description of the engine. Copyright 99 to 2011. So we said 2012. That's, I think that we're in the zone. And ACI copyright years others. Interesting. There's a help, so you can. The engine has a whole bunch of flags that you can pass to it. That's interesting. There's you can run a setup application on Windows. Oh, that's interesting. I'll bet you. Sometimes you might need to supply information like, hey, I want to use full screen, or I want to run in windowed mode, or I want to use this graphics device for my graphics or something. And, you know, I wonder if AGS, the engine, kind of ships with that built in so that you, the game author, aren't obliged to supply that kind of configuration in your game. You can just focus on building your game, which is what a good engine does. Let me be clear. I'm not a game engine developer. I am not a game maker. But I would say that this is probably uncontroversial. A good game engine allows you to focus on your game and not on the mechanics of getting your game to work. You know, it lets you focus on the fun stuff, the gameplay, and making a good experience for the people playing your game. And so the more that you can like offload to the engine, the better. Okay, so there's a bunch of other stuff. I think I'm going to blast past this. What's Penguin? Oh, so this is just an example. These are examples. Launch the game in specified directory, launch penguin.exe, or launch the game in the current directory. Okay, interesting. So you can supply, like, you can tell the engine to, you can point it at different game assets in different games. So this is also interesting. This is not int main. This is called process command line, main process command line. So instead of using something like, there might be a utility. It wouldn't surprise me if there's a utility in C++ to do this for you. I think in Python we'd use something called argparse. I know there's a Rust equivalent, but it looks like they're hand rolling their own argument parsing here. They have their own like AGS string comparison tool, or at least it's abstracting maybe the underlying platform string comparison, which is kind of interesting. And I don't begrudge them. Again, I'm not like criticizing or anything the fact that they're hand rolling this. Like if this was written, when was this written? Like if Chris Jones started this in 1999, I'll bet you a lot of this comes from that era. And so we're going to be seeing some old school stuff here, gang. We're going to be seeing some late 90s C++. And as a Firefox developer, you know, every now and then you bust open a C++ file, you're going to see stuff from the 90s. That's just the way that's the way it is with mature software systems. Sometimes you're going to just find you're going to crack a window and suddenly, or crack a door open, there's some 90s stuff in there. So I'm going to blast past this. This is just like argument parsing. AGS entry point. And this is calling main init. Okay, this is looking close. This is looking closer to what I would expect for an int main. It's not called int main, but it's returning an int. It takes the right argument signature here, and it's calling main init, and it's doing like malloc, setting up malloc and stuff. Like this is the stuff you want to do early on if you're going to set up your own allocator and stuff. Because that's what I presume is going on here is like, hey, we're setting up our own, maybe we're using a custom memory allocator or something, which Firefox does. We use something called JEmalloc, or mozmalloc. Maybe it's called mozJEmalloc now. We forked it. Okay, so let's keep going. Oh, where's int main? We got to the end of the file. Did you see that? We got to the end of the file. We AGS entry point. Where's int main? Did I miss it? I wonder. Here's int main for main SDL2. And main.h. So that's interesting. Main SDL2. History. So this is part of the work to replace Allegro's main with SDL main. Okay. They renamed main Allegro to main SDL2. So this is something you will see sometimes, is like you'll get this as a code base evolves, conventions that sort of developed from prior eras, from different epochs of the source code, will kind of echo forward. And so this main SDL2 is, we're inheriting a convention from when it was using Allegro. They had a main Allegro. And they just kind of like swapped out the Allegro bits. I say just. This was almost certainly a very complicated job to switch your underlying graphics and I/O abstractions and stuff. But they swapped it out for SDL. And so this is what's presumably calling AGS entry point. So this is your main entry point right here. You compile the engine, and if you're using, I guess, the SDL CPP, which I want to believe is probably used everywhere. Let's just take a quick peek here and see if we can get some. Is that, no, I don't want to look for the file. I want to look for mentions. Look for mentions of main SDL. See make list. If you're making the AGS app, we're using main SDL. Okay. I'll bet you too. So I want to, something occurred to me, which is that it's possible that when you build the editor, the tool for building a game, you also build the engine. Because one of the things that you want in a game building tool is the ability to play the game that you're writing. And so chances are either when you build the editor, you also build the engine in parallel so that you can like hand a built game over to it to try it out that you're developing, or somehow the engine is embedded in the editor tool so that you can like invoke it within the editor. It's probably one of those two things. Okay, so here's your main entry point, and we call AGS entry point. Let's see. Let's go back and see what that does. AGS entry point. So the first thing it's going to do is call main init. So we're going to go back to what we were looking at before. Set our EIP. What is an EIP? Set our EIP. What is EIP? In common. Set our EIP. So I will criticize one thing, which is that I'm not seeing a whole lot of documentation, inline documentation. Now, let he who is without documentation cast the first pull request. But like, there's certainly sections of the Gecko and Firefox source code that also don't have documentation. So that this is not a blistering criticism that I'm leveling on AGS. This is an observation that they're missing some inline documentation. That's fine. But that would make, I'm having to do now what anyone, I would imagine, would have to do exploring this code base, which is understand what EIP is and when they could have written it down. Like, I would imagine the people who are maintaining this definitely know what EIP stands for. I do not, so I now have to go dig it up. Our EIP is an integer of some kind. And it's and what's it used for? Our EIP. Get our EIP. Let's see what it's used for. Here it's used for error. The program has exited without requesting it. Program pointer REIP. EIP, is it? It's a pointer of some kind. It's a, what is an EIP? Early intervention program. EIP. Register that holds the memory address of the next instruction to be executed. We're maintaining an EIP. We set it to minus 999. Okay, so we're just gonna, for right now, that's very strange, but right now it's just saying, hey, remember this magic number. Okay, minus 999. Cool. Now we're gonna init some libraries. So we're gonna, this is probably text encoding stuff, UTF-8, file name encoding. We're gonna use Unicode. Makes sense. I'm not gonna dig too deep into that. It doesn't sound too exciting. There's some kind of construct called version, and then these are constants that I think we're probably inlining at build time, would be my guess. Am I right? ACI version string. And this we're building some kind of data structure that holds the engine version, and that structure also has information about, I guess, if there's a build string, we'll put that in there as well. And then, so now we get into the platform agnostic parts. Like, this is like the sort of, I don't care what platform I'm on, just hand me a thing. In this case, it's get me the driver for whatever platform I'm on. I don't care what it is. It could be Android, it could be Windows, it could be Mac OS, it could be the we could be running in a browser. We could be running on the space shuttle computer from, like, we don't know. Doesn't matter. Just hand me the platform driver, and then I'm going to send it the command args that we were given, and then I'm going to call main init on it. And I will believe, I'm going to go ahead and believe that this blocks. This is, as in, as soon as we enter this routine stays here until the game ends. Either the user quits or it crashes or something. The game will not, like, the engine does not proceed here. And the reason I say that is because I can see us, like, resetting things. Reset. Asset manager reset. I mean, maybe I'm wrong. Maybe it doesn't block. But, like, main init, you know what? Maybe it doesn't block. Maybe it doesn't block. Let's keep going. And the reason I say that is because main init was only the first thing that was being called. Then there's, like, other stuff in here. Like, we have to set up malloc. So I'm going to take back what I said. Main init does not block. That's probably more like setup stuff. We haven't entered the game loop, because that's where we're going to block, is once we're in some kind of game loop, where a game loop is we are looping and either, you know, I'm going to be very generalized here, but we're waiting for user input. We're also waiting for other events like time passing or you know, timer events or other game events, but we're spinning this loop, and those events will come up, and then the events may change the state of the game. Like, I don't know, the user clicked something, and so now we're going to send a character to go walk over there. So the state of the game might change. And then if it is time to paint, we will paint. Like, if we will maybe update the graphics that are displayed, and then we will start over. And we will do that until the game quits. Like, the user has, either the game has ended because the user has completed the game and they've hit the quit button or something, or the user has decided to quit because they're done playing. And then you exit the loop and the program exits. That is the standard, since time immemorial, that is the standard game loop structure that I'm familiar with. Again, I'm not a game developer. This is also the same structure that Firefox uses. Like, this is a, there's actually a really interesting relationship between something like this point-and-click adventure game and Firefox. you have the platform like Gecko. That is your web engine, and then you have your application Firefox written on top of it. You have your game engine here, AGS, and then you have games like Gemini Roo written on top of it. And they're not so dissimilar. They're not so dissimilar. You know, the game itself, or Firefox the application, is built alongside the engine that executes it, but they are kind of two distinct things. That's why in Firefox you might hear us talk about the platform team, or Gecko, as being distinct from Firefox. It's because they're tightly coupled, but they are two distinct things, conceptually speaking. There's a little bit of functional overlap, but you know, that is how we were able to make Firefox and use a lot of the same source code between all the different platforms that we develop on top of, or we ship to. So, you know, I've come full circle. When I first started, like, Simon the Sorcerer and point-and-click adventure games are the reason I got interested in computers, and I have this distinct memory. My memory is not very good, but I have this distinct memory of wanting to know how it worked. And so my first instinct was to open it up inside of, like, Notepad or the DOS edit tool. There was just a thing called edit in DOS, and I opened it up, and it was filled with this binary garbage. I could find some strings inside of it, because like the English language strings for the dialogue in the game and the menus, you'd find it at the very end of the file, and I found that interesting. But I was like, how does any of this work? And I was so interested, and I think you can draw a direct line behind me opening up that executable file in Notepad or Edit or whatever it was to where I am today. That is how I got here. Okay, let's keep going. Let me know if any of this is uninteresting and we can move on. But I'm having the time of my life. Okay, debug flags equals 0. So we've got some mixed styles in here. Again, I'm not criticizing. I would imagine, I suspect that they're not using any linting tools here. That's okay. You don't have to. But I'm seeing either multiple hands or multiple eras being represented here of different conventions. And that's okay. Okay. Config tree, startup ops, config tree. Okay, we're going to process the command line. That's that other function that we saw where the command line was being parsed. We're calling into that. We look and see if the result, I guess if it's not 0 is like your success case. This is like the equivalent of NSOK is 0, saying like, hey, everything went well. If everything didn't go well, we're going to return that, return that value. And if you follow the return chain up, the call chain up, we're going to exit. The program will exit. We'll just, like, the int main is going to return this number, I think. So if everything was okay with parsing, then we are going to, if attached to parent console. Where did that come from? Okay, so that's this, like, global, file global variable that was set up here at the top. And that is a state that a global variable that will set if we see the console attach flag. Okay, so as opposed to like getting some kind of structure out from the command line argument parser, we assume it's going to set a bunch of, like, I guess, global variables, and then we just read those global variables. Okay, that's fine. Not my favorite, but it's fine. Again, I'm not criticizing. I'm just really interested in how it's working. Okay, and then if we're just being asked to display the version, we'll write that out, I guess, the engine string, and we'll just we'll write to the platform's standard out, whatever that is, and then we'll exit. This is some constant, exit normal. That's probably just a 0, because that's like the standard exit code on for C++ programs. If you're like, if all has gone well, you return 0, as in like, we did it, everybody. If just displayed help, then we'll print help, the command line arguments, and we'll exit normal. If don't just tell me and don't hide message boxes, then we'll tell the platform to set GUI mode to true. I don't know what hide message box is. No message box. Disable alerts on modal message boxes as modal message boxes. Okay, so I guess there is a way like the platform can use like maybe platform specific dialogues. Like on Windows, that'd be like the classic message box, and GTK would be something else. And maybe the game engine knows how to do that. And here we're saying, okay, unless we're hiding those things, then we'll go ahead and like set GUI mode to true. So that presumably is like, yeah, go ahead and use the platform GUI. That's my guess. What is just tell info? If tell info keys size, tell info keys, string all, tell, dash dash tell. Print various information concerning engine and the game for selected output use. Print contents of merged game config, print paths, available config files, print engine name and version, print list of supported graphics drivers. So this is just like diagnostics, or like, here, dump out some information for me. Okay. Just tell info. So if we're not just supposed to be telling info, then and we're not supposed to hide message boxes, then go ahead and set GUI mode to true. There's some kind of like debug. It looks like there's a logging tool in here where you can like print logging stuff, like debug. Maybe if you're in debug mode, we'll print this to the console. Init debug. I think I saw a different file called debug, and maybe we can look at that in a sec. Look at the app path. Presumably, yeah, that's where we are, the engine path, and we're going to get the directory. These are probably platform specific tools, and it might be delegating down to SDL to do the file system stuff. Update shell associations and exit. If we're if debug flags and debug reg only, then exit normal. If we were only, okay. Otherwise, if we're going to use a custom exception handler, then if disable exception handling, then we will initialize the engine. If use custom exception handler. So that's interesting. A custom exception handler is interesting because we don't, if your program crashes, if your C++ program crashes, normally what happens is you exit. You get dumped right out. It'll say, the platform will say like segmentation fault or something equally unhelpful, and you'll just be down and back wherever you launched it. Sometimes, the operating system, if it's like a Windows or something, it might say like your program program encountered an error. Mac OS, it might be like your program crashed unexpectedly. You might get a bunch of different experiences. Now, as a program author, that's not great. I mean, as a game player, that's obviously not great. But as a program author, sometimes it's useful to get information about the crash. Firefox has this exact same thing. We have something called the crash reporter. So what we do is you can tell the operating system when you're setting up your program, hey, install a custom exception handler so that in the event that we crash, before we crash, let me do a couple of special things. And it's I wouldn't call it a black art, but it is a very interesting discipline. Learning how to be like, there are specialists at Mozilla who know our crash reporting stuff, and they're specialists because it's a weird state to be in, because your program has crashed, but you're still kind of running. You are in a known bad state, and your memory could be completely corrupted. That is the state that you're in when you're crashed. You could be in you can't trust anything. It's a bit like you've just been ejected through the windshield of your car and you're in midair. So you can't press the brakes because you're no longer in the car. You have smashed through the windshield. Now, what you can do is look at your surroundings and quickly write them down, stuff them into a letter, maybe lick it closed, and throw the letter into the ditch before you hit the pavement. That's a very graphic description of what crash reporting is like, but it's kind of that. You are in midair, having smashed through a windshield in a car accident, and you kind of go like, "Well, how did I get into this state? Oh, I blew through that stop sign. Let me write that down. Blew through stop sign at Main and 3rd Street. I'm just making stuff up. And here's what I was doing at the time. I was looking at my phone. I was looking at my phone at the time. Shouldn't have been doing that. Blew through a stop sign. Put it in an envelope. Lick it closed. And then huck it into the ditch. And then impact the pavement. And then every now and then, a robot goes along in the ditch and looks for letters. Goes like, oh, here's one. And sends it. Puts it in the mailbox. Yeah, so that's how that works. So that's what's going on here. Is it looks like AGS has this ability to set up a custom exception handler in the event that you want crash reporting. Now, the only reason that I can imagine you'd want crash reporting, I mean, maybe there are others that I can't imagine or haven't thought of, but is so that you can repair your game or repair your engine. So presumably it's possible to write a game that will crash. The engine's not perfect. Maybe it's just AGS that receives these crash reports, or maybe you're a developer like Wadget Eye Games. You want to make sure that your users are getting a decent experience, and so you set up something like Sentry, and you're getting like crash reports sent to Sentry that you can like check out. That's possible. Fun fact: Mozilla and Google collaborated on the very first. I don't know if it's the very first, but we collaborated on the crash reporter that is used by Firefox and used to be used by other Chrome and other projects, I think. I don't know if it was ever used by Chrome, but it was definitely used by other Google projects. Mozilla and Google collaborated on that like in the early 2000s, I think. It was called BrakePad? BrakePad. It was formerly called Airbag. 2007. We're renaming the Airbag project to BrakePad, which feels a better name. And yeah, it was actually Google's project, Google BrakePad, but like we collaborated with them on it. I don't know what I'm looking at here. Back when Google was using Subversion. They were using Subversion. 2007. It was a simpler time. Anyways, I've gotten deeply distracted. Let's keep going. Initialize engine. We're about to get to the interesting part. Initialize engine. Where's that coming from? Let's find out. There was something else I wanted to look at too. What was it? No, I don't care as much. Let's look at initialize engine. I think that's probably going to be more interesting. Here it is. Engine.cpp. Now, we are in a fairly long file. I just noticed that. We're in like a file that is 1,459 lines. So this might be the last file we get to look at because we've only got like a half hour left. But I think there's a lot of interesting stuff. I would imagine if we're talking about looking at the game engine and how it works, looking at engine.cpp is going to be pretty interesting. Here, I'm looking at this game engine. I'll also say this thing, which is that the strategy that I'm deploying to explore this game engine is working for me. Like, I am slowly but surely getting a picture of how this thing works. It helps that I have an understanding of how Firefox more or less works, and that I'm noticing similarities, and that's allowing me to kind of like fast track a number of things and make a bunch of assumptions. You would find, if you wanted to do this exact same thing with Firefox, finding int main is going to be a real challenge. If you've tried to look for int main in Firefox, you're going to find a bunch of them. And you will be like, I guess this is maybe where you want to start, is inside the NS Browser app for Firefox. But a number of abstractions that we get to before we're actually like doing web browser things is immense. We have to set up all this stuff. And so this isn't always the best strategy that I'm deploying right now for exploring a code base. Like, I think AGS compared to Firefox is probably much smaller and much simpler. It's much more focused. They're similar in that they're run times for running stuff. Firefox and Gecko, and I should say Gecko, is a runtime for running untrusted web content that is downloaded over the network. AGS is its engine is it's interpreting games written for AGS. So the scope is a lot smaller. But yeah, looking at int main, I don't know how fruitful it is when you look at the Firefox source code, because you are going to go down this rabbit hole of abstractions, and you might go like, when do I get to like doing a network request? Like, isn't that what a web browser is? When do we draw a thing? And you will be in here for a while if you start from int main. So where do you start? If I was trying to point someone at the Firefox source code and saying, here's where you can sort of like get started in understanding what the browser is doing, 2 places. The first one is called Browser Glue. Well, first of all, I would assume that the person I was talking to understands and is comfortable with JavaScript. And I would point them at Browser Glue, and I would point them at browser.js. And I would say, Browser Glue is run once in the parent process at the very beginning. It's I think it is some of, if not the earliest JavaScript that is run in the browser is Browser Glue. So this is going to run a lot, like I would check this out. It's setting up a lot of stuff. And then the other one is browser.js, and this is run once per browser window, including the very first one. And you can think of browser.js as like the index.js of a browser window. If browser.xhtml is index.html, you can think of browser.js as index.js. It is your, like, an instance of a browser window is definitely running this. And that's where I would start. And they're long files. Browser.js is over 7,500 lines. Browser Glue, we're chalking at almost 7,000 lines. It's a lot of JavaScript. But that's where I would probably tell someone is like, if you're willing to ignore the sort of the platform agnostic stuff of like setting up standard out and exception handlers and stuff, read those 2 files and come to grips with them. And they are large and they are unwieldy, but they are a better indication of what the browser is first doing that is like browser-y as opposed to platform-y. Okay. Engine. So we've got this big file, engine init backend. I'm just going to blast through a couple of functions and wait until I find initialize engine. So we've got something called engine init backend, win close hook. That sounds very Windows specific. Engine setup window. These are nice small functions. This is a static fill game properties. Okay. Engine run setup. This is that setup application we were talking about. Where I guess you can choose things like, hey, do you want to use your WebGL, your GPU instead of the one that's integrated to your chipset graphics or something? And it looks like that's only working on Windows. It looks like. Okay. Find game data in config. That's interesting. Search for game data file. Engine init fonts, init mouse, locate speech pack, locate audio pack, assign asset paths, init keyboard, do nothing. Brilliant. Init audio. Danny Colin says, I'd also give them a 6-pack of beer for surviving browser.js. Yeah, browser.js, not too much fun. Better than it used to be. It's actually been split out. It used to be a lot longer. It was like over 10,000 lines at some point. And then my colleague Heist started to break this up into different files. So that way, if you look inside here, you'll see some different files that start with browser dash. And those all, I think, used to be inside of browser.js. So if you're thinking that, oh man, browser.js is unwieldy, was worse before. And I think it goes to show just how efficient the browser engine is, and that it like parses all of this stuff in like milliseconds and like deals with it in milliseconds. Speaking of documentation and code, Smurf D, winky face. Yeah, I hear that. Now there is some documentation, I will say. Like we've got some in here. Hey, come on, go easy. Every now and then we get a nice comment block, but yeah, this is an older file. But sometimes we have documentation, and Hey, all right. I'll say it again. Let those without documentation cast the first pull request, or those with full documentation. Only those with full documentation. And at this point, maybe that's the SQLite people. Okay. Engine init audio. So we initialize, I guess, the audio drivers. Init debug. Okay. Exit handler. Load game data. Resolve configured path. Init user directories. Okay, blah, blah, blah. Check write access. To do. Remake / remove this nonsense. Nice. Engine check disk space. See, that's helpful because like you are going to write some stuff. You're going to write configuration files and you're going to write save games. So yeah, sometimes you need to make sure that you've got some space on your disk. Check the font was loaded. Show preload if there's a preload graphic. And it's some sprites. H error. I wonder what that is. Engine init game settings. Okay, that's interesting. We're just gonna fill the structure with some bits and pieces. Set up SC system auxiliary. SC, is that scripting? That might be scripting. SC system. Prepare to start game. That sounds good. Define game data location. Check all. Where is the initialize engine? Define game data location. Init and engine init game data. Read config. Prepare config, set config, print info, engine print info. If you're wondering why I'm not just like finding and like pressing enter, it's because I want to see all these directories anyways. And editor debugging. Try connecting to the external debugger. There's a debugger server? That's interesting. I'm getting the impression that there's like a way you can connect a debugger to the scripting engine that's running and you could like debug your game. That's kind of neat. Good for them. Okay, here we go. Initialize engine. Haha. To do. This function is still a big mess. You know what? Respect. I think it shows a maturity. I think it shows rationality and maturity if there are apologies in your game engine. Or if there are apologies in your source code. That's a good sign. It's a bad sign. It's also like, okay, there's stuff to maybe apologize for, but it's also a good sign, meaning like, okay, I know that there are things to improve here. There's a humility. I get the sense of humility. And that's good. You want humility whenever you're working on a software project. Not like this is the only way to do this and I'm the best and you know, I'm a big tough game engine developer and I know exactly what I'm doing and anyone who doesn't is an idiot and blah 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 blah, which is endemic. And I'm not going to name names, but there are game developers and game engine developers who are definitely in that camp, and they are not to be. You can learn techniques from them. I wouldn't learn how to be a human from them. Okay, this function is still a big mess. Engine system related initialization is mixed with game related data adjustments. Divide into parts. Move game data init other init game state or other game method as appropriate. Okay. There's a pre-init callback if there is a engine pre-init callback, which is null to start with, but I guess you can set one up. Maybe if you are in the platform specific stuff can set up a pre-engine init callback, and if so, you'll call that. Interesting. Install the backend. What does that mean to install the backend? Here, we changed our EIP again to 199. I don't know why we're doing that. What is that magic number? But okay. And then we'll call in the platform, we'll say, hey, we're in pre-backend init. And so by backend, they must mean SDL. Okay. Initializing the backend libs. So we'll go ahead and try and sysmain init, which presumably that's your SDL stuff. Yeah. We're going to do all our SDL initialization here. And if that failed, then we'll get the error and we'll print it out, and we won't print it out. We'll display an alert. Now, depending on what platform we're on, that might be a modal, a platform modal, or it might, who knows, maybe it'll go standard error or standard out or something. And then install Allegro. Are we using both? Install Allegro. Are we using SDL and Allegro? Return install Allegro version check. There's a lot of macro stuff in here. Okay. And then Allegro and make version. Install Allegro. Lock variable. So now we are in like the Allegro library. That's very interesting. We're doing some initialize stripped Allegro library. What is a stripped Allegro library? What do you mean by that? What do you mean? What do you mean? Disable Allegro system driver. Game processing is not fit for a single event pull, as well as game thread may be looping a certain state for a while before returning to the main loop. Task from the time we were adding event polls into each substate. Install Allegro. Set up Allegro. We got rid of it. SDL pump events. As part of this commit. As part of the SDL port, replaces Allegro 4 backend with SDL. Tidy it up. SDL is used for all these things. Allegro is kept in a stripped form for memory, bitmap handling, drawing, file path functions, Unicode text functions, and decoding flick videos. So they use it a little bit, but embedded. That's interesting. So there's a hybrid, at least at this point. There's like this hybrid SDL Allegro application. Sorty says, must be some part that SDL does not have Allegro files. Like, I guess what you're saying is like there's certain things that Allegro does that SDL doesn't do. That's possible. I'll say another possibility, which is that there are some ways that Allegro does things. Like it sounds like what they're using Allegro for is for like some graphics memory stuff. And I'll bet you SDL does some of that stuff, but I'll bet you Allegro does it differently enough, and that a lot of that difference is like kind of deeply embedded in the AGS game engine, how it uses Allegro, that switching over to SDL is like a bigger task, in the same way that like adding promises to a JavaScript library can like have rippling effects outwards. You know, I don't know if you've ever experienced that, but like if you make a thing such that it returns a promise rather than returns a value, like a value immediately, it returns a promise that resolves that value. There's like rippling effects. You know, anything that calls that thing now also need to return a promise if it like relies on, like there's just like changing signatures like that can like or typing a code, like adding types. Yeah, or adding types. You know, it can ripple outwards. Okay, and then post backend init. Okay, so we set up SDL. We set up a little bit of Allegro. We run post backend init. I don't know what that is. That's going to probably be different per platform. And then we return true. Okay, so the backends are initted. Engine init backend. Connect to the external debugger if required. I think that's pretty cool. You know, they have their own language. They created their own debugger tool. That's good job. if that interests you, this idea of creating your own language and like a debugger for that language, and like how does any of that work, I have some recommendations. The first one is called Crafting Interpreters. This is a free book you can read online, but you can also buy copies of it in like hard copy, or you can get it for your Kindle or something. I highly recommend this book. This is wildly readable. Crafting Interpreters. If you want to know what it's like to make your own language, just as an interesting exercise, but also just to understand how languages work and like what goes into language design. I think it's just like a neat thing. It's a little bit like learning how how a cabinet is made. You might not make it into a living, like making cabinets, but it'll change how you look at like furniture. I'd say building a programming language is more complicated than building a cabinet. Maybe it's more like renovating your own kitchen or a bathroom. So you have to do all the plumbing and electrical and stuff. Like, you will walk out of that process knowing a lot about maybe tiling, woodworking, electrical, safety, drywall, joist, waterproofing, stuff like that. You'll learn a lot. So Crafting Interpreters, I think at some point it talks a little bit about debugging. I could be wrong about that. I read this a few years ago, and I got a hard copy, and I'm kind of like a quarter of the way through it, and then I paused. I need to read it again. I don't remember if it has debugging in it, but you can just read it for free right now. You can read the whole thing on the web right now. Garbage collection, methods, superclasses. Yeah, it doesn't, I don't think it has anything about debugging. But so here's the free copy if you want to read it. Read for free here. Here's another free book. This is by my friend and mentor, Greg Wilson. This is a book you can also read for free online. Let me find where the copy. Software tools. Yeah, stjs.tech. What? Where is it, Greg? Greg. Software tools in JavaScript book. Is it just here? Read free sample. Where's the PDF? This book is free, I'm pretty sure. Yeah, like here's the source code for it. The website appears to be down, but this is the source code. It's like written in the Creative Commons. What's neat about it, I mean, you can build the book yourself, but it talks about how lots of interesting things that you use, all the tools. Free with membership? Nice. Some tools that you use every day that you maybe take for granted, like version control, it talks about how they work and how you can build a simple one in JavaScript. He has a similar one called software tools in Python. Is that? No, maybe not. Maybe it's just the JavaScript one. But one of them is a debugger. We're going to build a debugger. How does a debugger work? Debuggers, where's our starting point? So like this is not very readable right now because this is used to generate the book. There's a graphic in here, but like if you can get a copy of this book, it's very interesting because he talks about how you can like build a debugger for a fake language, and then like there's source code in there. I think you build like a really, really, really simple language, and you build a simple debugger for it, and like that kind of thing, very helpful for understanding how stuff works. Is you just build a simple version of it. And he also has stuff for like how to build a build tool, or a code generation tool, or a backup tool, or a regex parser, or a unit testing framework or a virtual machine. Like he goes deep. This is from my friend and mentor and grad supervisor, Greg Wilson. If you've ever written or if you've ever read Beautiful Code, you might know him from Beautiful Code. He helped make Beautiful Code happen. And I think he was like one of the lead editors on this book. And it's discussions with a bunch of software developers and how they think. And he wrote Architecture of Open Source Applications. This one's also for free online. Here, I should put, where did the other one go? I'm getting distracted because I haven't, we're not looking at AGS right now, but I wanted to supply you these resources. Architecture of Open Source Applications is interesting because it's like a bunch of discussions with software professionals working on pieces of software you've probably heard of, like Audacity and Eclipse and, the Firefox release tooling. Now, some of this is a little out of date. Like, this is written at this point maybe a decade ago. But you might find it really, really interesting. And then, like, there's performance stuff. 500 lines or less. Experienced programs solve interesting problems. Oh, that's interesting. There's a whole series here. Anyways, some of that might be interesting. All right, let's end strong. We've got like 5 minutes remaining before we close out the year, close out the episode 388. So it's gonna like locate the game data and pull together the game config. Makes sense. Then it will init the game data. So what I'm interested in is interpreting the game data. So it's doing all of this stuff to like find it, find the configuration, get all the stuff, set up the game options from user config. So like we'll find a configuration file, and then again EIP. Okay, we're gonna change that magic number. We're increasing the magic number as we go. This must be like a way for us to know where we are when things fail, maybe? It's very strange. Okay, we assign some things. I want to get to the part where we launch the game. Exit handler, set the game speed. Okay, then we do a big jump. EIP went from 199 to -10 to -20 to -19 again. What is happening? And then load game data. That's interesting. I want to look at that. Engine check disk space. Check font was loaded. At least one font was loaded in the process of loading the game data. Adjust for rotation settings. Interesting. Attempt to initialize a graphics mode. Configure game window after render was initialized. Set up multitasking. Window show cursor. Hide the system cursor. Show any preload. Init some sprites. Could not load sprites. Move init game settings to game init code unit. And then initialize start and play game. That's the other part that I really want to see. So engine load game data. Loading the game file. EIP is going around. We're going to load the game file. Where is that? Where is that? Load the game file. What is H error? I don't know what H error is, but okay. That might be like a custom error. I don't know. Main game source, we create these objects on the stack. We're going to read the game data from game entities, from game. Where's game come from? Is it global? Yeah, game struct. Game setup struct. Okay. We'll load the game entities. Open main game file from default asset. Read game data. We'll read it in. Custom engine detection. Ugly hack. Depends on the known game ID. So if we're using... So the game engine has a UUID or a GUID to identify itself, and if we find that the game that we're trying to read is for a custom game engine, either of these two, the ones for Kathy Rain or Whispers of a Machine, then we will poke this value in. Then there's like a version of the game engine. We will do like some special tweaks for games of a particular version. Custom Edge Clifftop. So we'll change the resolution here. Search the assets for old style audio files and recreate clips array. We do this separately after. So I guess this is almost like migrating forward. You know, games written long ago. This game engine is from like 2000, whatever it was, 2008? Long ago. 2009? And so games written right from the very beginning, I guess they need to be able to like migrate that data forward without necessarily like altering the game, because the games might be frozen. The author might no longer be maintaining it. The sources might be all lost. And so we interpret the game assets, we recall what the old form of things used to be, and then we migrate them forward in memory. Load game scripts. Load game scripts. Oh, load game scripts. That interests me. There's going to be one called the global script.o, and then we'll create, there'll be this stream, pscript, script, create from stream, global script from the asset manager, looks up the game scripts available as separate assets. These are optional, so no error is raised if some of them are not found. For those that do exist, reads them or replaces any scripts of the same kind in the already loaded game data. Interesting. Dialogue scripts, script modules, list. And we just like read them in. We read the scripts in. Okay, fair enough. And then I kind of jumped around there, but init game state, then mark GUI. Okay. Engine load game data. And then the most important part, initialize start and play game. Let's find that. And we're basically at time, which is a bummer because we're about to get to a really interesting part. But maybe we can just spend, let me just check my calendar real quick. Hold on. How much time do I have? Okay, I'm gonna go just like for another minute or two. But let's take a look at initialize start and play game. Game start. So we're in this file called game start. So we wrap this whole thing in a try catch. Fun. I guess because we might get a, in the event that we get an Ali 3D exception, we'll quit with that special message. Otherwise, I guess we'll continue to throw. We set the cursor mode to mode walk. No matter what, we start with cursor mode walk. We say that the player character, which is another global, I guess, character info player character, okay. If there's an override start room, I guess it was passed in as an identifier for a room, okay, and we'll say that the player character is in that room. Engine initialization complete. Starting the game. Load save game on startup. Only start if not restore to save. Okay, well, let's pretend we're not loading a save game. We'll go to start game. And then this is, I think, our like main loop. We'll enter here. Run game until aborted. So displayed room, start game. Set room placeholder. We're in mode walk still again. This is the default position for the mouse. I guess we might play some music if possible. EIP again. Skip ticks to account for initialization or a restored game. And then we'll run a script function, game start. So that could do a bunch of stuff. If displayed room is less than 0, then current fader effect, then we'll load a new room, the player room, and the player character, and then we'll initialize the first room. I think that seems to make sense. Like there's like this notion. I think this is true with Scum as well as SCI and AGI, is that the main unit of one of the main units is the room. There are actors and there are rooms, and you know, every screen is a kind of a room, even if it's like the menu of the game. In the game, that might be a room. It's just like a one graphic room with like some buttons to click, and the character doesn't walk around in it. That's a room. First room initialization. Starting room, displayed room, player character, previous room is, so we remember the previous room that they were in. We set the loop counter to 0. Reset the background frame state. Okay, we set some state, and then that, where's that, like, yeah, run game until aborted. That's the last thing I'm gonna look at. That's the last thing we're gonna look at. Skip ticks to account for time spent starting the game. And then, because like ticks is, I think it's almost like a counter that's used to determine where we are, like how much has time progressed, I think, which is important sometimes for knowing what state we are in the game. Because things like forward progression of an action might use ticks to like measure the progression of forward momentum. Smurf D writes, well, how to change value of EIP and Ollie D. I saw find location once set your EIP to reset. In addition to the reply above, the EIP is basically the pointer to where the current line of execution is. It's used to keep a record of which instruction the program is executing in memory. Maybe something similar to the above for what EIP is. Yeah, you know what? I think you're right. If I had to guess based on what I read, it is a very, if you'll forgive me, AGS editors, a fairly hacky way of indicating where you are in the program, so that in the event of like a crash or you need to debug something, you have like an identifier of like, okay, here's where I was in the program when things maybe went sideways, and it's like a new magic number. That's my guess. Yeah. So while not abort engine, we'll do game tick, and if we're loading a new game, run AGS. We'll load a new game. Otherwise, we'll just do game tick. What is game tick? Game tick. Run a single game iteration. Update game once. Update mouse over location. And then we're done. So wait, hold on a second. Run game until aborted. So it'll just do that in a loop. It'll just do game tick. Game tick. Game tick. Update it. So there's your loop. There's your loop. Game loop until event. This function is called from a lot of various functions in the game core character. Game loop until event. Loop until event. Blocking cutscene and skipping. So this is like a nested event loop. Effectively. Begin a nested event loop in our game. Loop here. And then it ends again. So block the game loop until something occurs. We have those in Firefox as well. Nested event loops. They are not great, but sometimes that's just the way it is. We do it differently if we had the time. If we'd known, we wouldn't have done it in the first place. So that I think is basically it. Like, we haven't gotten into some of the fine-grained detail here on how this game engine works, but I think we've gotten to the point where the game is running. And like, we're doing the more interesting stuff now, which is to update game once. What was it? Update game once. Which is this is gonna like update the game state based on user input. Update game once. We called it with a single argument. Okay, so yeah, there are some default args. Update game once. If one, exit, proper exit. Notify script still alive. Game loop, check problems at start. Here's a EIP stuff. Check, run this immediately to make sure it gets done before fade in, like a player enters the screen. Handle player input. Do the overall game state update. Update objects scale and the cursor over location and audio system. Render. And then wait for the next frame. This is your main game loop right here. This is a tick of the game. This is the important part. For next episode, Mike's building a game engine in JS from scratch. Oof. You know what? It's kind of fun sounding. I think I'm probably going to go back to Firefoxy things. I like to do these for special holiday episodes, but it's a neat idea. That's why I got into computing. I wanted to know how point and click adventure game engines work. And I think I've reached the point where I think I understand it. And writing one is maybe the next step. Who knows? I don't have any great ideas for a point and click adventure game though. And that's the thing that you need to making a game engine is a fun theoretical exercise, is difficult, but it's probably easier if you have a game in mind where a custom engine that you either want to learn. Writing a game engine is usually not what you want to do if your main intent is to make a game. Making a game engine is interesting if you want to learn. It's a great opportunity to learn. Or if your game needs to do something that none of the other engines can do. And so as a learning exercise, I think that'd be fantastic. I'd love to make one. But I think as a learning exercise, I'd also need a real adventure game to want to make. I'd want to have like an end goal of I have this whole adventure game design that I'd like to have work on a computer. That would probably help. Anyways, I think I'm going to call it there. Hey, thanks so much for watching The Joy of Coding, episode 388. This is a very special holiday episode. I don't normally do deep dives in other people's source code outside of Firefox. So this was a special holiday episode. I wore a special hat for it. Next time I stream will be on January 8th, hopefully. I'm taking a couple of weeks of holiday, and we'll continue our journey to document customize mode and improve our documentation there. And let me know what you thought. There's a rate this episode form. You can use this to even wish me just a happy holiday. And people are doing that in the chat. You have good holidays too. Thank you, Smurf D. Thank you, Danny Cullen. Anyone else who's watching, have yourself a great holiday if you're taking one. If you're whatever you're celebrating, I hope it's a great time. And Happy New Year. And here's the link to rate this episode. Drop that in the chat there if you want to rate this episode. Let me know what you thought. Maybe you like this. Maybe you'd rather I do this instead of look at Firefox things. I don't know. But let me know what you thought, and I read everything that comes in. I'll happily read it. And yeah, have yourselves a great couple of weeks, and I'll see you in the new year. Take care, everybody. Bye-bye.
The joy of coding.
See ya.